So, these are our objectives today. And when we talk about this, we were making sure that we understand when we talk about substitution. Like that's when we choose one of those numbers that we determine meet that criteria. Like if we say x is less than 20, what do we know is less than 20? What? Yeah, but what number could we say is less than 20? Let's pick a number. 19. Right. Any number that's less than 20, right? So we could substitute that number, and if we're looking at it on a graph, how would we know that that graph is actually meeting that inequality? What tells us that?
Well, sometimes you see the graph, you see the number itself, then you'll see a circle. I believe it's a regular circle, not shaded in circle, darkened circle, and you will see the numbers going back. So you see like a circle, and then going through the line, it will be going backwards. Then like you have to watch it.
Okay, so I hear he said like a darkened circle, you said closed circle. What are those both are what? They're describing how they're like shaded, right? In on the line. And what does that signify to us?
It could be that number or less.
It means that it could be that number. And he said that it was going back, right? And talking about back, what did we talk about? He's pointing down this way, and I'm facing the other way. So he's talking about pointing down this way. Which way is that?
That's the left side.
It's going left, right? And when we talk about a number line, when we go left on a number line, what does that mean? And I've got two people that are they're like, you're doing such a great job. Can I get, thank you?
Negative?
Numbers that are on the left side of the zero are negative numbers, yes. But are all numbers that are on the left side negative?
No.
No, but they are another word that we're looking for. Less than, right? Because if I'm 20, yeah, negative numbers are going to be less than, right? But there are also some other numbers that are going to be less than too, right? So, but we're talking about left of a number is going to be lesser value, okay? Do we understand that? Maybe? Less? Okay. All right. So we're going to be looking to substitute numbers through looking at that graph, looking at that darkened area, that line, and see if it's shaded in, and see if it is making the statement true. Okay? See if that's true. And then we're going to make sure that we understand that inequalities have this infinite amount of possible answers, right? Because we can know that the answers to x is less than 5 can go on forever and ever and ever and ever, right? Because there is no end to the number of possible answers, right? So we need to understand it could go on for millions of numbers, right? So we need to make sure we can understand that. And then we also have to be able to graph any inequality, whether it is less than, greater than or equal to, or less than or equal to. You will notice that some of you got the graph organizer. That graph organizer is to help you, right? It's to help you get a little more organized and help you where you might need some help, okay? It's okay to use that if you need it, okay? Now, on your sheet of paper, you have it where it says warm up. Everybody see where it says warm up?
Yes.
Okay. I want you, where where it says the number line? Everybody see the number line?
Yes.
I wanna see what we know, okay, just right off the bat. Using your graphic organizer if you need to. If you don't need to, then that's okay. I want you to graph the inequality x is less than 5. I want you to graph x is less than 5. X is less than 5. When you do this, after you do it, then I want you to take turns, you and your partner, and explain what you have done. If you are by yourself, I'm gonna probably grab you real quick and put you with someone, okay? Explain why you did what you did after you do it, okay?
So how is X bigger than me? So how is 5 bigger than X? I can hear you. What you saying? Well, I'll put 5 going like to 1 to like. I'll say X is like going this way. That's what I would think.
Alright. Is it? Oh yeah, it is. So what you're saying is that x equals 5. I see that too.
Because x is what into of the end. So it's x. So it's
You're right.
because it equals that's 4 and x equals 5.
And we're looking for x is less than 5.
X is x is less.
Yep, x is less than 5.
X is less than 5.
So what are you going to do with that?
We're going to turn by x to the 6.
Remember, if you need to check.
So this is the 5. And what's less than 5?
So to help prove your reasoning.
4.
Yeah. Yep. There you go.
Okay, so I shaded 4, 3, 2, and 1 because 5. Dang it! It said it has. Yeah, it has to be less than 5. And
So should it start on the 5?
no, you can't start on the 5 unless this has the line in it, because that means it's less than and equal to.
I think that means if it's shaded in, then it would be the same or equal to.
Oh. So we do start on the 5. So I was right. So you do start on.
Yeah, but you'll just do a circle,
Yeah, I did.
but not fill it in.
I think x is less than 5 because it's less than it does not have the line, so it's not a darkened circle. It's just an open circle, and it it's also shaded in.
Yeah, so we see this, and so we see that it says, for our example, it says x is less than 8, right? So then what do we see for our graph?
We see.
Okay, so it says the number is less than 8, and then our graph is starting when? It starts on what number? So it does start on the 8. And how does it start? How does it start? What does it look like?
Circle around the line.
So is it filled in? Remember we talked about that darkened circle? Yeah, because can it be the 8? So it can be, so it does say it could be equal to?
It can't be the 8, but it.
Yeah, so that's why it would be, right? So that's why it would be an open circle, right? Do we understand that? Right, because we darken things in, right? When it can be the answer. But this one's not darkened in because it can't be. But we would start it on the 8 because it says less than 8. So right, but this one is an 8. What number is it?
Oh, 5.
So where would we start our number at?
5.
But if we put it up here on the number line. And then where would we go with it? Where are the numbers? Which way do we go when the numbers are less?
That or subtract.
Okay, when we subtract, which way do we go on the number line?
Left.
We do go left. So that darkened line would go to the left. Good job. So go ahead and draw that line pointing down to that left. All right, so remember, once you get done, what happens with your thumbs? You go up. Yeah, you hold them up. All right. So, how many of you at first felt a little uncomfortable? Raise your hand if you felt a little uncomfortable at first, right? Okay. Thank you for being honest, because again, sometimes, is it okay to feel a little uncomfortable? Yeah, right? Because being uncomfortable means we actually are starting to get some learning happening, right? How many of you are, after you had some discussion, and I know that some of you were helping each other, and how many of you referred to the graphic organizer, and the graphic organizer helped you? Right? I know that I have one group back there that definitely, good job. So I want you to make sure that you are using the graphic organizer and use the tools that you're given, right? Okay? Now, what was the first thing that you needed to do when you looked at this?
Make sure you understood it.
You kind of got to make sure that you understood it, right? You kind of got to make sure that you understood what it was saying, right? So, just like the words we read every day, right? We got to make sure we understand what it says. So, what does this say to us? What does it say to us? Thank you. I'm going to try to get somebody I hadn't heard from yet. Okay, so this says, now she read it backwards, and it's so funny because I was getting ready to say, could we read it a different way? She she took my thought process and said it. Because I was going to say, after somebody read it this way, I was going to say, could we say it a different way? Because she said it, 5 is greater than X. These things mean the exact same thing. They do. But they look the exact opposite, don't they? But they mean the exact same thing. Because if I put a number here, right? If I put a number here, let's put a number there. Somebody give me a number that would. Okay.
5. I said that. 4.
Okay, I got numbers yelling at me. Okay. All right, my bad, because I just said give me some numbers and y'all did start yelling at me. So that was my own fault. Give me a number also. Say 2. So if I say 2 is less than 5, is that a true statement? Yeah. It is a true statement, right? Now, if I put this same 2 in this statement, is it true? 5 is greater than 2? Yeah, it is. So when we went back to our objectives, to be able to substitute to determine if our given number is making the set true. Are we doing that? We are absolutely doing that, right? Whether we are writing it with the X on the left-hand side or the X's on the right-hand side. Because you could see it either way. The key is looking at if it gets reversed, the inequality must get reversed as well. The inequality must flip around as well, okay? But really and truly, you gotta know what it's saying, right? You gotta know what it's saying. And remembering that when we talk about the number line, somebody, I can't remember who it was back here, said, well, this means that we're gonna be subtracting because it's going to the left. Yeah, on a number line, when we subtract, we're moving to the left. Great job. When we are adding, we're going to the right. The number's getting greater, right? Really good job. Really good job. The next thing I want us to make sure that we're doing is that we know that this number can go on and on and on and on, right? Forever. Because you see that line doesn't stop, does it? Because it just, when we graph this, right? When we graph it, and I'm going to put this 5 right here, this 6, then this 4, right? And y'all have a lot more numbers, right? And again, I think we had some people who got a little bit confused about the open or the closed circle. So can somebody want to help me and talk about why it would be open or why it would be closed circle? What would be the difference between an open circle and a closed circle? Landon, tell me why it would be open or closed. Landon, I'm sorry, I couldn't hear you if you said something, babe. And if you have to look at your graphic organizer, then that's okay. So do we know the difference between the open and the closed circle? So Hunter, do you know the difference between the open and the closed circle? Okay, all right. So we've got a learning moment, right? We've got a great learning moment. So how many of you know the difference between the open and the closed circle? Okay, all right. Kevin, tell us all about it.
The open circle is that answer cannot, the number cannot be an answer as well.
Okay, so if it is an open circle, okay, it's an open circle, it means it cannot be the answer. So remember at the beginning of class we talked about how anything that was shaded in and darkened in, it was a solution, right? It would make the inequality true. So this is a less than, right? And on your graphic organizer, it talks about this or this being or equal to, right?
Good afternoon.
This
May I have your
is
attention, please, for our
not
announcement?
this
Mr.
one,
Reminder,
right?
students, please make sure you are following.
So that's why
all
it would be
the protocol.
open.
Students, so if you're a ride and
Okay.
you're a car rider, if
All
your
right.
ride has parked.
How many of you feel like you met your objectives today? Kinda. How many of you feel better about it anyway? All right, good job, guys.
I was confused putting a dot at 6 and then going.